Hi everyone. Let's take a look at this interesting optimization problem. We want to find what is the maximum vertical distance between the line y equals x plus 2 and the parabola y equals x squared on this interval x is between -1 and 2. So let's go ahead and make a sketch so that you have a visual idea of what's going on here. So here's our x and y plane. So y equals x squared, we know it looks something like this. This is our parabola, y equals x squared. And y equals x plus 2, it's a line with the y-intercept 2 positive slope, so probably something like this. So now let me be more specific. Something like that. Let's do that. So here's the intersection, believe it or not. This is where it's going to intersect at -1, and this point right here will be 2. So it satisfies the interval we're given. So we want to know where's the maximum distance from here to here. So let's put a vertical distance from the line to the parabola right here. So we want to know what's the maximum distance. So a point on the parabola can be written as, so let's say right here, this point will have the x coordinate x, but the y coordinate will be given by x squared. And the point on the line will be given as x coordinate as x, but the y coordinate will be x plus 2, because that's our equation will give us. So we want to find the distance between these two arbitrary points, and then we'll take the derivative of that function, the distance function. So the distance, we know the distance formula is going to be d is equal to, so we take x minus xo minus x1, or you can do in any order. So let's consider our second point to be this one, the first point to be that one. So we'll take x minus x squared plus, now the second point is x plus 2 minus the first coordinate, that's x squared squared. So that's how you get the formula. So remember, I'm just subtracting the points and I'm figuring out what's the distance between them. Now, we know that this is going to be 0. So x minus x, that's 0. So our distance formula simply becomes the square root of x plus 2 minus x squared squared. That's d. And then here we can also freely cancel the square and the square root to get the absolute value. So d is equal to the absolute value of x plus 2 minus x squared. Now, since we're going to be looking at the maximum distance, we want the positive distance, we can avoid the absolute value in this case. Now, this is our function, d of x. So you can call this a function. Let g of x be a function of x plus 2 minus x squared. So I'm just rewriting d as a function of x. Now, let's take its first derivative. So we take the derivative of g respect to x. So g prime of x will be 1 minus 2x. And now we're going to take our derivative and we set it to 0. So we'll have 1 minus 2x equals to 0. If you solve for x, you'll get x equals 1/2. There you have it. That's the x coordinate. Now to check, this will give us the maximum distance at this x value. You can take the second derivative and verify that. So that means the maximum distance, we simply plug in the x value in here, we get the d. So d would be equal to x, which is 1/2, plus 2 minus 1/2 squared. And that's going to give you 1/2 plus 2 minus 1/4. And if you combine, then you'll get 9/4. So that'll be the maximum distance between the parabola and the line between within the given interval, -1 to 2. All right, I hope this helped you understand this problem. I'll see you next time. Take care, guys.